Okay, yeah, I would like to introduce Annunziata Kenya. She is a software engineer with a passion for building user-friendly global standard mobile applications. She also firmly believes in the power of communities in fostering learning and growth, and actively organize Android 254 community in Kenya and Kotlin Kenya developer communities. She's also part of the DreadCon Kenya conference. Additionally, she serves as a Women Tech Makers ambassador in Nairobi. And outside of tech, she does enjoy dancing. Yeah, take it up, Anne.
Thank you, Jane. Just turn off my camera. So yeah, as Jane has said, that's a bit of the introduction. My name is Annunziata. I help organize Android 254 and Kotlin Kenya developer communities. And yeah, I think that intro is sufficient. So I'm gonna go ahead and share the screen so that you can start the session. Let me know when you can see my screen, Jane.
I can see a screen, Anne.
Great. Just a minute. Okay. I hope the bar for Zoom is not blocking part of the slides. Or is it all?
Oh, sorry, Anna was on mute. Yes, it's okay. We can see the Zoom thing.
Oh, great. Yeah, so that's part of the introduction. Today we'll be covering Unit 6. So if you've been following the Android Study Club, we've been going through the Android basics with Compose, and we've covered a bit of the units as part of the study group, and we are now in Unit 6. So I'll be taking you guys through data persistence, specifically with the Room library. Yeah, so next slide, this is a bit of the sessions that have been done in the past. So we had the Unit 3 composed by Jane. There was one on navigation by Madonna, and also Unit 5 by Sierra. So for today's units, you don't need to have fully gone through all the others. You'll be able to still catch up with this, but in case this is something that you'll be interested in, feel free to check out the previous ones. Yeah, so what we'll cover for today's session, we are going to have an introduction to what data persistent is, then go straight to Room library, the Room components, performing operations with Room library, then talk a bit about migrations and testing them. Then we'll have a sample demo project to look at how the code is structured, and yeah, test out how whatever we've learned is running on an actual project. Yeah, and so what is data persistent? So it's basically storage of user-generated data to ensure the data created from an application process is not lost when an app is closed. And there are different ways of persisting our data. So you can choose to persist. So for example, let's say an app interact with WhatsApp. You're able to chat with someone, but then if WhatsApp was not able to persist your chat, then if you come back to the app, then you don't have that data anymore, or the history of your chats, right? So that's basically the essence of being able to persist data. And there are two options for persisting data in terms of the Android applications. There's persisting them remotely or locally with Room. So remotely, you can interact with an API that sends your data to a server, or you can also store it locally, or in some instances also you can mix a blend of the two. You have some data stored on the server, and also some that you choose to store on Room, but mostly for offline access, because most people are kind of trying to have offline accessibility or offline fast apps. So yeah, so that's the remote storage we've talked about, the remote server, local storage. I've mentioned Room, but there's also something called data store. Data store is also part of Unit 6 of the Code Lab, but today we'll be looking in depth into the Room library. Probably to mention a bit about data store is usually for minimal sets of data. So for instance, let's say you have an app that a user logs into the app, and then you don't want the user to come back to the app and have to log in again. So how do you store the state of the user is already logged in. So probably that such an instance you can use a data store, because you don't need really to do a whole database to just store if the user is just like one property or field. So data store is for minimal sets of data. So room is for more structured data, which I'm going to talk about today. Yeah, so what's the room library? It's part of the Jetpack Compose library, and it provides a wrapper around SQLite. So SQLite is what you use for database in Android, and it's a relational database, which basically means there's relations between tables. So first of all, there are tables that have columns representing properties, and rows that now have different instances of the data. So a good example is this image I have over here. You have how ideally a database would look like. So you have the ID, you have the name, you have the completed. So these are the columns represent the different properties. So if you work with Android applications, you probably worked with data classes. So if you're interacting with the data classes in the UI, from the database perspective, how does this look like? Because you can't store a data class, a coding data class into the database. It needs to be transformed to something else, which is this table that you have over here. And that's what Room ideally allows us to do. The models or the data classes we have, transform them and store them as tables in our device for offline access. Yeah. So we talked about Room, then how are you able to set up Room and use it in your applications? So Room has three main components to be able to set up and use. So there are one, the data entities, there's data access objects, there's the database class. We're gonna go through each of them and how to be able to implement each of them, sorry. So I'll go to the next slide. So the first one is an entity. It represents a table in your apps database. In the previous slide, we've talked about how you normally interact with the data classes from the UI end. So the entity in terms of Room allows you to convert that data class to now be stored as a table in Room. It also provides ways of customizing the table that will be represented from your data class. So for instance, yeah, I think the first thing I should have mentioned also is, so if you can see the code here, you have the data class item, it has these properties, but at the very top, we have something like entity. So you need to annotate it with that entity annotation to be able to tell Room that these data class actually supposed to translate to a table, and you can choose to customize the name. So by default, if you annotate with entity, you can leave this as an optional field, and Room will create a table that is named what the data class is named. So ideally, if we didn't have this table name, Room would create for us a table, but name it item. But on our case, we want to customize and call it to do item. So that's why we have this table name attribute here, but it's not mandatory, although the entity is mandatory for Room to be able to know this should translate to a table. The other thing you can customize is the column information. So yeah, the first thing is Room checks the model, the name of the class will translate to the table name, and then each of the attributes that you have here will translate to a column in the table. So you have a column called ID, you'll have a column called name, you'll have a column called completed. The other bit is you can customize the column name. By default, it will be the name that's already on this model class, but you can customize it to now what you want the table in the actual database to be named. The last bit to probably mention is the primary key. For relational databases, there needs to be a primary key that uniquely identifies each item you save or try to retrieve in a database. And by default, Room provides a way to auto-generate this primary key. So you have to annotate it with a primary key. And if you want Room to be able to generate these values for you, put the auto-generate to true. Else, if the data that you'll be saving, if it already has the primary key somewhere, you just annotate with primary key, then you don't have to generate from Room. Let's say this data is coming from backend and the primary keys are already like set in backend as long as they're unique. Yeah, so in this instance, you are auto-generating from rooms. So if you start at 0, room will just, sorry about that. If we start from room, room will automatically now increment from 0. The next, if you save the first item, it's going to be 0. The next will be 1. The next will be 2. Like, yeah, that way. So every single item that you save will be unique. The next thing to mention is if you have a data class you're trying to convert into a table in room, but there is a field, say you don't want to be saved, you can have annotations such as ignore to be able to tell room, I don't want to save this column as a table, this property, sorry, as a column in my database. So there are other annotations that you can check out. There's ignore, there's something called embedded for a different purpose also. So there are so many other annotations probably you can check out and see how they work. So that's what the entity is, basically representing a table in our database. Next bit is, sorry. The next bit is a data access object. So data access objects basically provide a way for the app to be able to perform operations. So I have the database, I have tables that I have stored in this database, but now how do I access, let's say I'm trying to add something into the database, I'm trying to query the database to get something to display for the user. So the data access object is now the interface that defines the customizations of what do you want to, what kind of interaction do you want with your database. So there are different methods that are provided for the data access object. So there's convenience methods that don't require you to write a lot of complex, no SQL statement at all. So there's something like insert, update, delete. So if you look on the side where we have the code snippet, it's an interface, you name it your custom name that you want. Then, so for this specific app that you're working on is an app to be able to save to-do items and show the user the to-do items they have for the day, say. So insert, update, and delete, you really wouldn't need to tell the database what to do to insert. So ideally, if you didn't have a wrapper like room and you're interacting with raw SQLite, you'd need to probably write an SQL statement. For example, insert into this table, add onto column this, add this value. But in this instance, you just put the annotation at insert, and in the background, Room is able to generate your SQL statement for you and actually do the insert. So that's why it's a wrapper and uses complexity for you. So you have insert, you have, for example, update, you have, yeah, so it's insert, update, and delete. But then for other probably more complex statements or queries, you will use the query annotation. So examples, but for the query annotation, now you'll need to add a bit of an SQL statement to explain what complex thing you want to do or operation you want to do to the DB, sorry. So for instance, you want to fetch data, a list of data from the database, you want to return a subset of tables, of table columns. So you have a table that has ID name and the status of the to-do item, but now I just want to check the status and show somewhere like how many, or maybe I want to do a count of how many to-do items have I completed for today. So in that case, now you can use at query and then write the SQL statement of what you want to achieve. So an example is these two part of the code snippets that we have here. So we have get all items, and then you have the SQL statement that you're writing to the query annotation. For example, select everything from to-do item. The second one that also adds a parameter is get items by priority. So I want to fetch, let's say, my to-do list items, but where the priority, I've tagged the priority as high. So you can be able to do a bit more complex queries or statements using the query annotation. Yeah, the last bit to probably note in terms of data access object is there's something called on conflict strategy. For instance, so let's say you tried to add an item to database, but then in an instance where you're passing, let's say the primary key, and you add it, but there's already an item that exists with that primary key. So in terms of room, that will be a conflict because you're trying to insert, but there's already something that exists in the DB. So instead of the DB failing, how does room sort this conflict? So you can do on conflict ignore, replace, or fail. There are different on conflict strategies that you can explore. So yeah, you guys can also check out a bit on that. Yeah, so that's the data access object. The last component that you need to set up is, yes, the last component that you need to set up is the database class. So this provides the database instance and serves as the main way to access the actual database. It defines the list of entities and provides the instances of the data access object associated with this database. So we've created our entities, which are supposed to be tables in our database. We've created a way to access these tables in the database, but then you need to now actually create the actual database and provides the functionality to now access it. So this is how you define the database class. First, you have to annotate with a database, just the same way it was mandatory to annotate at entity and at data access object. I think I forgot to mention that. At database, at the DAO, you need to annotate that, and then yeah, so for the database class, you also need to annotate that. And then the next bit is you need to list for this database, what are the tables or entities that we have in the database. So for our case, we just have an entity called item that stores our to-do item. So this database has basically one table, if we say that. So if you have more than one, if you want to have more than one table, again, you define another entity, you also add it to this list. The other bit is also versioning. So if this is the first version of your database, you need to put it as one. If you come back later, let's say we change our entity or we add another database, we need now to take it to the next version. And probably we're going to talk about a bit about versioning and how schema changes as we go. Yeah, so there's the bit for annotation for database. Then you create an abstract way to access your data access object that will allow you to actually now perform operations on your database, like inserting, all that. The last bit is we create the instance of our database, but as a companion object, because we want to have only one instance of our database. If we had multiple instances, we'd have the app doing different operations, and we'll not be having the same updates to the data, because different operations probably have different instances. So we need to have it as a singleton. That's why here we have the companion object bit. And yeah, so you create a database builder, create your database here, and then this is the name of the database, so how the database will be named. The last bit probably to mention is here, where we're initializing it to null. We also have the at volatile, so annotation. So this annotation basically tells room that no values, let's say when you're accessing or when you're trying to get the instance, should be cached. So all instances should be from memory. So you shouldn't be like accessing a cache. Let's say when you're trying to get a list of something, it shouldn't be cached. All the instances should be like in memory. So you'll be getting up-to-date values if you're trying to pick something or updates. Yeah, so that's for the database class. Yeah, so you've defined your entities, which are basically tables. You've defined your data access object, which will allow you to do operations. You've also defined a way to get the instance of your database to do these operations. So how do you actually go ahead to perform the operations? So basically, you will get to call the data access object methods from your repository for the different operations based on how you've set up your architecture or your application. So you have the database set up, you have the database access objects, and if you remember the code snippet we had on the database access object, there's a way to insert, there's a method to delete, there's a method to update and also query the database. So you call these methods from the side of, let's say, the UI, when you're trying to fetch, when you're trying to delete, and all that. So a different diagram probably to show the flow would be this. So you have the view. If you're using MVVM architecture, probably you'll have the view, you have the view request, the view model. The view model will get to the repository where the repository gets from the different data sources. But in our case, it's specifically room. Yeah, and then the data comes back and you're able to access it now on the UI end. So I'll show a snippet of how the code looks like. So you have your repository here, and your repository has different functions, and these functions actually call a function in the database access object. So if you remember, there was a database object, access object method to add items. So we call that method to be able to now add items. Then this method is later on called in the view model. So for example, you have a delete one, you'll have a delete here. And probably the other thing to note is this suspend keyword, because like operations, database operations are not supposed to work on the main thread. So you need to use a suspend keyword to run them on a background thread. I think if you go back to, let's go back to the database access object, you'll see, yeah, these operations also have the suspend keyword. These two don't have the suspend keyword because they are returning a flow, and a flow basically runs on a coroutine. So you don't need to put a suspend. It will just be repeating yourself. But yes, generally you need to run it on a background thread with this suspend function. And I think the good thing with Room also is it has integrations with other libraries, for example, flows. So you're able to return your data as a flow in terms of, instead of probably just a general list. So you can return it as an observable. Yeah. So let's go back to, yes, we are here. So yeah, so call them in. So the assumption here is you're using the MVVM architecture. So call the database access object in the repository, call this consequently in the view model, and then on your UI end, yeah, it seems like I forgot to add the screenshot. On your UI end, maybe where you're trying to, you click on delete an item, probably you have an on button click action that says, when you click this button, now call this function in the view model that actually now calls this, and in the background is able to delete this item in your Room database. Yeah, so that's on being able to access it after you define the database access object and the database. The other bit before we probably do the demo of the sample app that we have is, that's good to mention, is migrations. So you've been able to ship out the first version of your app as version, the Room version is the first ever version you've shipped out to your users. So that's version 1, right? But then as time goes by, you're improving on your application, probably you're adding features, your app is growing. Ultimately, your database will also change. So let's say you'll add columns to your database, you'll want to add another table because you have an additional feature. Yeah, and now you want to ship this out. But when you ship this out, the first version you ever shipped out, let's say, was version 1, right? The user downloaded the app, the user is currently using the application, and data already saved on the device, for example, for just one table. And you're migrating this table, and you're telling the user, now we have 3 tables, and probably you've changed the name of one table. So how will Room know how to move the existing user data to this new structure that you have, because the database schema has changed? So that's where migrations come in. You need to be able to write migrations or tell Room how to now be able to migrate correctly without having the app crashing on the user, or even worse, the user losing all the data and now they're starting from scratch. That can be a bit of, you know, a bad user experience. So, so options that we have for Room migrations are automated migrations and manual migrations. Yeah. Close this, yes. So for automated migrations, they are available. You're using the room version that's from 2.40 and above. So on the lower ones, it's just manual migrations. And then automated migrations basically work for very basic schema changes. For example, you've added a new column to an existing table. You're trying to rename a column that already exists. And automated migrations work by comparing the versions that you have in your database. So version 1 and version 2 that you had. And then for a bit of ambiguous schema changes. So for example, you have renamed a table, but probably Room would not be able to do the automatic migrations without a bit more information on what has changed. You'd need to add auto migration spec to give Room input on how to actually now do the automated migrations. We're gonna go through one example. So the next bit is manual migration. So this works for more complex schema changes. For example, you're trying to split data in a table into two tables. You're trying to add new tables to the table that was existing. And then for this, you have to use raw SQL statements to actually tell Room how to do the migration. Yeah, so you need to explicitly define a migration class and then write statements to tell you Room how to migrate it comfortably. So this is an example of, sorry, this is an example of, have this bar here that is blocking on my end. Let me move it to the top. Okay. Yes, this is an example of a migration. So a migration that moves it from version 1 to version 2 and defines and tells Room that this new migration is supposed to create a new table called fruit. These are the columns and the data types for each column. You have another example of migration from version 2 to version 3. And then when you go to your database builder, which is the database class we talked about earlier, you're able to add those migrations to your builder so that when the app is run and then they're trying to update to the new version, these migrations are then run and the user's data comfortably moves to the new version that now you have put out. And the last bit is because migrations ideally, so we said at first if the user has data, you've made schema changes, but you haven't told Room how to migrate. If the user actually runs this app, they run into the issue of probably their app will crash or they're gonna lose all data. And then the solution we've said is actually having specifying migrations. But what if you've written the migrations, but these migrations are wrong in a way or are not working? So being able to write tests for the migration will help you before shipping your app, will now help you make sure that these migrations will now work in production and the user will be able to comfortably ship to the new version. You can write tests and also check using the database inspector on how the new application translates in terms of the tables that are there and your database in general. We'll also look at the database inspector in the demo. And yes, I think it's now a good time to go to the demo. And before we probably go to the demo, just a reminder that if you have a question, probably you can also throw it in the comments. Then after we're done with the demo, we can now take the questions. So allow me to stop sharing so that I share the app. I share the actual sample projects. So I hope I'm sharing my my Android Studio screen. Someone can confirm.
Yes, you are.
Great, thanks. Thanks, Jane. Yeah, so I'll quickly take us through the structure of the things we've talked about on setting up. So this sample, I'll also share a link to the sample app. Yeah, so the main focus was on the room aspect. So the way you decide to structure your packages or go about, let's say, naming or writing is completely up to you. But this report is basically to go through room specifically as a library. So I have, first of all, you talked about the entity. So we have our entity here, and we have the ID, we have the name, we have completed. We have renamed it to column name and then customized also the table name to do item. After the entity, we have also defined our data access object that has these functionalities to basically do this, running on a background thread. So we have a functionality to add, update an item, get all items, get items by status. We have last the database class that does define your entities, instances of the data access objects that you have, in our case, just this one, and yeah, builds an instance for you to be able to work with the database. And we have named our database to do database. And then we said after you define this, you should call them from, let's say, a repository. So for instance, if we click on add item, you're able to see we are calling them from this repository. This is just a catch block. For example, if I'm trying to add an item, something goes wrong and it fails, we don't want the app to crash. So that's why I have the try catch here. But based on the use case of what you're working on the app, you may decide to do different actions when it fails here. So probably try adding or re-adding or something like that. So yeah, you're calling the data access object functions in the repository. Then in your view model, you also access them again. You're not running it, you have to scope it on a background thread so that it's not blocking the UI in any way. Then for instance, yes, the view model function where we're trying to show a list of our items. Sorry, let's work with delete. That will be easier to follow. So for example, deleting an item, we have a list, we have the screen that shows our list of items. And then for one specific item, when someone clicks on delete, then you're able to call the function to delete. So the flow has moved from all the way from the UI to the database we have, and back. So I'm gonna run this app so that we see how it looks like. Remove my phone screen so that you guys can see. Yeah, so yeah, so ignore how the UI looks. I'm sure it could have been better in terms of making it more beautiful, but yeah, let's just focus on how the functionality is currently working. So you have
Sorry to interrupt you, Anne. Hi.
Yes, hi.
We can only see Android Studio Code, but we can see the emulator. I'm not sure whether.
Okay, let me just try reshare again. Okay. You can see that my phone screen is actually not emulator.
Yes, we can see that now. Thanks.
Great. Thank you, Jane. Yeah, so you have the app here. It should show a list of items here, but there's none that's showing here at this point. Yeah, obviously, if it's a production application, you probably want to show a text here saying you don't have any to-do items at this point, add to-do items or something like that, instead of just showing a user blank screen that may not be very direct. Yeah, so let's try and add an item. Yeah, so we have a dialogue here. So let's say a to-do item for me is cook dinner, and then we want to add it. And you can see that now it appears on my list here. Let's add another one. Let's say do laundry or listen to music or something. And now I want to check how room is looking. So I have the database inspector here. If you probably can't see it on your tabs here, a way to pick it up, go to view, go to tool appearance, go to app inspection, and you'll be able to now have this tab where you have the database here, and then select the device where you're running, if it's the emulator, if it's a physical device, and then the exact process that you're running. So in my case, this is the package or app that I'm running. And you guys can see that now we have these two items that we have added. We have, if you remember on the model, we had our primary key as something that auto-generates. So a room automatically increases it from 1, 2. If we add another one, it's gonna be 3. Yeah, so let's try probably add so that we have a visual of it. Say listen to music. If I refresh our database here, we can see now we have a new item added to the database. So that's being able to insert using our database access object. Let's try probably update an item here. So cook laundry, I want to check it as something that's completed. The other bit is, yeah, so for Boolean values, they're not stored as true or false. They default to 0 and 1. So 0 is false. 1 is true. So now that our completed value was a Boolean item. So if I refresh this, our value should move from 0 to 1. So cook dinner should move from 0 to 1. So you can be able to see how your database changes. If I say delete do laundry and refresh, yeah, you can see now we don't have do laundry anymore. But yes, so we've been able to do the basic room operations. The other bit we discussed is migrations. We talked about automatic migrations and manual migrations. So we can do a demo of probably automatic migration. From the collab, migrations are not part of it, but it can be a quick mention for this session. So just close all this so that you're not bombarded with a lot. So I'll go back to our database. So we said that migration will happen ideally when your database schema has changed. So you've made changes to an existing table or you're adding new tables, basically modification of the schema that's already there. So I want us to go to our item entity or data class, and then add this new column. So in terms of our to-do items, we've added a column called priority, and you have a default value for it as low. So probably let's run and see if this update actually goes to the user. Are they going to be able to successfully keep using the app the same way without you having to do anything on your end or try some migration? So if we run this app, let's see. Yeah, so the first error, so let's pass the value here now that we've added it, run it again. You can see the app crashes on us. So let's try and see what error we are getting. Yes, the first error is room cannot verify. Let me close this so that we're not distracted. Yes, the first error we're getting is room cannot verify data integrity. Looks like you changed schema but forgot to update the version number. So the first step you're gonna do is update our version. So we had the version as 1 here, so we're gonna move to the next one. The version is 2. Let's run it again and see if the app will work comfortably. Let's minimize this again. Clear the errors that were initially there. So the app runs, but the user is not getting a bug. Let's see what error they're getting. Yeah, so our migration 1 to 2 was required but not found. So we moved from version 1 to 2, but we haven't been able to specify a migration. So in this case, you can, because it's not a major schema change, we just added a new column. This will be an automatic migration. So we need to be able to define an automatic migration for Room to be able to know for migration to 1 to 2, this is what should happen if there was existing data or from the schema that was there initially to a new schema. So for that, for automatic migrations, we mentioned that automatic migrations compare the schemas that were there from the old to the new schema. And a way for the schemas to be compared is we need to specify a directory for where the schemas will be for the comparison to be made. So if you go to the Gradle file, there should be this that now specifies the location that the schema, the database schema that Room should use to compare in the migration. So there's this that needs to be there. So we have defined this already. So yes, we've updated the version to 2. Sorry about that. So what we'll do is, let me just comment this out for now. Yeah, so we need to, on our database, we need to fill the auto migrations value here. So we'll have an auto migration moving from 1 to 2, which is the versions we moved from. So because this is a very basic change, this should be able to work. So I think the other bit that I can share is the JSON files that are created and saved in the directory for the auto migration for comparison. So is it? Yes. If you check here, we have schemas. We have the schema for version 1, and you can be able to even check for your app how the schemas have changed over time. So you have the first version we had ID, name completed. I don't know if I ran this after or before, but it has the priority. Shouldn't have the priority field. Let's see the second one. But yeah, version 1 should not have the priority. I don't know if I ran it before. Yeah, it's because I've run it after. But version 1 should not be having this value that we've just added here. Yeah, so we've defined a migration from 1 to 2. Yes, now let's run and see if all goes well with our application now that we have defined the auto migration. Yeah, and our app works okay. So let's go to our inspector. Connect this and run again. Let me reconnect the device. Sorry. It's not picking up my device. Let's just reconnect it again. Just a minute. Okay, so added our migration. Um, let's go to the database. Okay. Okay. So it's bit. Not sure it's not picking up. Let's see. I'm seeing there's an error. Migration didn't properly handle. Okay. This could be because our schemas look exactly. We didn't pick up the correct version 1 schema. So let's try if we're gonna see if we're gonna be able to regenerate the actual. Oh, just a minute. Also comment out this bit and the view model. See, comment out this. Allow me to delete this so that we get the correct version 1. Okay. Okay, we plug in. The one inspector picks up. Okay, at least we're picking it back up. The inspector back. Let's see. Okay. So if I refresh this, hope the version is version 1. Yeah. Okay. Let's now move to 2. Create a migration. For that and add a new column. So where you're adding an item, we need to add this value. So where we are adding our item, so we're gonna have another value for priority. Let's rerun this. The schema one is not still being generated, and I already deleted it. But yeah, so sadly, I don't know why that migration is not working through, so that you can have a demo for it. But the schema one that should have been there was supposed to not have the priority value. Then the new schema, which is schema 2, is what we've added the priority value to. And then we have defined our migration here, the auto migration from 1 to 2, that will now migrate comfortably from 1 to 2, since the migration for adding a column doesn't require you to write an actual manual migration or add any more input, since that's a bit of a basic schema change. And I think that's mostly it for I think we mentioned for auto migrations, there's the general one where you don't have to have inputs. There's the second one where you have to have an auto migration spec that kind of gives a bit more information if Room still is not able to migrate your database comfortably. And I think the migration error that we've just had is just a testament of you should be able to test your migrations before you actually ship out the app. Yeah, so that's a good consideration also, like for being able to test for especially manual migrations, not the automated ones. But yes, I think that's mostly it. I'm also going to share this repo. I've linked it in the resources. Let me just go back to my slides. Yes, I've linked the repo in the resources. I'm going to push the code for the changes for the migrations. And if you need to check it out, you can check it out later. And yes, I think that's about it for today's sessions. I'll take.
Okay, thank you, Anne. I think she dropped off. Let's give her like 1 minute to join back. That was such a great session. If you have any questions that you have not added yet in the Q&A section, you can feel free to type in the chat section or add more on the Q&A section. Can you guys hear me? Okay. Let's give her a few seconds. So in the meantime, we can just have a recap of the things that we have learned. If there's anything new that you have learned, please let us know what you've learned in the chat section. For me, I have learned the different crude methods that we have. Yeah, I think she's joining back. Hi, Anne, can you hear me? Hi, Stephanie. Anne says that she is not able to unmute, but I think she is a co-host now. Anne, you can unmute yourself.
Yeah, sorry guys about that. I forgot to plug power back in. Great. So I was at the point where I was saying I'll take questions, but now unfortunately I've lost all the questions in the chat. So probably Jane, you can go.
Yes. Thanks.
Yes.
Such a great and interesting session. Yeah, and the demo was actually very interesting. So we have a few questions in the Q&A section. One from an anonymous person. He or she was requesting you to please repeat why we need a companion object in the database.
Okay, I'm trying to pull up the slide so that I can still share the slides in case you need to reference that. So let me do that. Yes, so the question is why we need a companion object for the database. So we want to have only one instance of the database that we are accessing or performing operations on. So we don't want to have two instances where there's a place where it's being updated, that instance, but there's another instance that's being accessed, because in this way, the data for, let's say there's a different instance that's being updated and then there's another one being accessed, then the data won't be correct for all instances. We want to have one instance that if you're performing an operation on, that's the instance you're able to update. If you're trying to access, that's the same instance that you access. So you want to have it as a singleton, not multiple instances of the same database doing different operations. Yes.
Okay, thanks. While you were presenting, I saw at volatile annotation. What does that do?
Yeah, let me share again. So the at volatile is also still on the instance of the database. So at volatile, basically, for any variable that you annotate at volatile, what will happen is that the values for that variable will never be cached. So you'll never have an instance where the database is cached and let's say you're trying to retrieve data, you're retrieving data for a cached version and maybe the database has been updated. So room, all the accesses are done in memory and not any cached values. This way, again, you're able to maintain the same database for all accesses, for updates, if that makes sense. So there's no it just ensures there's no cached version of it. You're just accessing the same in memory instance of the database.
Okay. There is another question on migration. So it is from Kibet. He's asking if you reach, let's say, 3 migration from 1 to 2, 2 to 3, and 3 to 4, and if someone installs the app with the latest release being version 3, will it run all the migrations?
So you've migrated, you have 1, 2, 3, 4, and then you've done what? Just read it again.
Yeah, so there's those migrations from version 1 to version 2, 2 to 3, 3 to 4. Then as a person, a user installs the app while you are at version 3. So he's asking, will the app run all the migrations?
There are two instances. One is the user is installing this app for the first time. So that means they don't have a different database schema. They just go straight to version 3. So for this instance, there won't be any issue. But let's say the app was, the user had installed the app on version 1. They never updated to 2. Now it's 3. So this is where also the migration across different schema versions comes in. So you can have a migration from 1 to 2. You can write a migration for version 1 to 2 and a migration for version 1 to 3 or 1 to 4, such that if a user updates the app from whatever version they are at, actually the migration goes through and they're able to comfortably move up to date with the latest schema that's there. And the other bit is also have the question of being able to have migration tests so that you ensure migration from version 1 to 4. If someone migrates from 1 to 4, it actually goes through correctly based on whatever, if you've written a manual migration, the statements you have actually work and the user is correctly moved to the new schema. If they're moving from 2 to 4, still it works. So yeah, you can have write migrations across different versions. Number 2, write tests for those migrations to ensure when it actually goes to production, these migrations don't fail the user on whichever version that they are in.
Okay, does that mean each migration should have its own test?
I think it's best practice, yes, to have them. So for migrations test, there's a migration you can do for each individual migration, like one version to the next, and you can write tests to run across all the migrations. So I think it's best practice to have the test, because also the other thing is, as you're adding or adding more features to your app, I think the migrations are from, let's say, schema 1 to schema 2. And as you're developing, this is something that is incremental. So you won't have one point where you're, I'm trying to see how to explain. So you have version 1, you've migrated to version 2. So before shipping, you'll have to write a migrations for just 1 to 2. If you move to 3, you'll be writing now 2 to 3, and the next one, if you're in the older version. But to answer your question, yes.
Okay. Then I've also been seeing people talking about AppSat annotation. What does it do?
So when we were talking about the database access object, I think I should pull up this, my slideshows again. Share my screen. I hope I'm still able to share. Okay, yes, I have access to be able to share. Can you see my slides, Jen?
Yes, I can see.
Okay, so move this. Yeah, so when we talked about the data access object, so there's an relation to be able to insert, there's one to be able to update, there's the query where we said it's for a bit more complex or custom queries that you want to do. But now there's something that you've mentioned called AppSat. So insert, so let's say you insert an item, and this item already exists in the database. If you remember, also you mentioned the on-conflict strategy. So let's say you can have a strategy like ignore or replace. So AppSat works like replace, such that if you try to AppSat is tells the database, try to insert this item. If it exists, update the existing item. So you can also use AppSat in place of where you want to do insert, and then if there's another item, instead of having their own conflict strategy, just replace it. So AppSat just tells you insert, if there, update.
So can I just have AppSat instead of having insert and update? So I just have one function instead of having two.
Yes, that's ideally the use. Yes, that's ideally the use of AppSat. So if you do, instead of at insert annotation, you write at AppSat. This add item function will try to add this item. If this item is already in the DB, in the DB, then it will just try and update the existing value. So yes, you can use it in place of insert.
Okay, thanks. There's a follow-up question on the migration. So Theophilus is asking, does migration also work with primary keys? And for example, my table schema had an int primary key that was auto-generated, and I'm switching to a string primary key that is user-generated. How would that go with migrations?
So migrations will work for all schema changes, which can be if the database schema is changing in terms of additions of columns or changes to the table. Changes can be you're adding columns, you're modifying the existing ones, or you're also changing the data type. So yes, it will also work. In that case, you'll need to then, because if the user has existing data, there needs to be a way for that existing data that was, let's say, integers to move to string. So then in terms of migrations, I think you need to consider that how the existing data will be converted to now the new data type, but for the existing data, if that makes sense.
Yeah, I think so. Okay. If you still have any questions, please feel free to add them in the Q&A section. So my last question to you, Anne, was, are there any strategies that you can put in place to optimize room?
By optimize, you mean?
Make it faster.
Make it faster. Well, I really don't have any strategies in mind, unless someone actually has any strategies in the chat. But I'm also wondering why you're trying to optimize. Is it that room is slow, or you feel like it's slow in accessing and probably doing updates, or why are you trying to optimize?
Yeah, when we have a large data set, or how does Roam handle large data sets?
You're trying to retrieve, let's say, get a list of items, but it's a large data set, or
yes.
Okay. The only instance I can think about is probably items that you show on a screen, and then you have, say, a column where you're showing items, or let's say a recyclable in the other one, and then you're picking, but that one, the strategy would be using a pager that you're pulling per limit. So the first, let's say 20, the next, like that. But no, yeah, I can't think of strategies. But yeah, I think if someone has any strategies in the chat, we can get that. Yeah, Banner comes to mind in terms of making it faster when it comes to data sets. Maybe people can also chip in the comments. We see what ideas are there.
Okay. This is my last question. What of those data that are like embedded, maybe a certain data class has a list within it, does Room accept all types of data like lists and maps, or how do we handle that?
There are data types, right?
Yes.
Okay. So they are initially the data types that are allowed in SQLite, but maybe as a user, you may want to have extra data types. So an example is date and time. It's not a native, I think, SQLite type. And a way usually around that you can use Room to be able to still save this is using, for example, type converters. So for dates, you use type converters to save this data into Room and also retrieve it back to the user from Room. So some of them can be able to customize that are not existing, to customize and still save in SQLite. That an example is that date one by using the converters. That's the only one I've actually been able to experiment that's not existing and convert. So I don't know how much more you can be able to customize and save, but the date and time converters is one example of being able to save the ones that are not SQLite based, but still convert across to be able to save and retrieve.
Okay. I think that's all questions from me. Thanks so much, Anne. I'm not sure whether we have any other questions. If you have a burning question, you can just unmute yourself for the next 1 minute, and then we can end the session.
I think I'll stop sharing now.
Okay, don't think we have any other question. If you do have more questions, you can reach out to Anne on our Slack channel, or feel free to ask any of your questions in the Android Study Club channel or the Android Kotlin. Yeah, Theophilus has raised their hand. Yes, you can unmute yourself, Theophilus.
Theophilus, we cannot hear you. I can see your mic is unmuted, but we can't hear.
Can you hear me now?
Yes, we can.
Okay, so still on the question on changing, migrating the primary keys. Let's say my question was, let's say, for example, you have an int, your primary key was integers and you're migrating it to string. What happens to the existing data? Because that was a major question. Like, so you are migrating and it's trying to, will it try to convert the integers to strings and then still save them, or what will happen to the current existing data?
Yeah, I have, sorry. Yeah, so I haven't tried an instance of migrating such a thing, but for the primary key, I think that's something the table ideally cannot not have a primary key. So if you're trying to change the type, I think in terms of your migration, you have to write a strategy for the application to be able to convert. So what I would think is when you're writing your migrations, write a way to convert the existing ones a converter for the existing ones to the new data type, from int to string, how the representation for that will be, how the existing will change. But yes, I would lie to say that I'm sure that's how it should work. So in case someone else probably has an idea around that, they can share. But yes, I don't think you can just change without showing a strategy for it to move to the new data type, because something like a primary key, the table can't exist without a primary key. And if you're changing, then we can't clear out the column to be empty because a primary key is needed. So I would think a strategy would be able to convert, but that's something probably you can look into more, beyond just this answer. Yeah.
Hope your question has been answered, Theophilus.
Yes, I'm seeing Malcolm is saying type converters. So yeah, Theophilus, there's that. Yes, on the chat.
Okay, I think that wraps our session. Thank you so much, Anne, for the great session. It was very insightful. I learned a lot. Thank you, everyone, for taking part. Malcolm is asking whether you are hiring. Yeah, maybe.
Unfortunately, no, I'm not hiring. Yeah, I'm not hiring, unless probably Jen or Stephanie, but no, I'm not hiring.
I'm also looking to be hired. So yeah, I'd reach out to me on LinkedIn or Slack. Yeah, thanks so much, Stephanie, for the platform. And thank you to Women Who Code. Think we can just hang out. Stephanie, we can. Yep. Okay.